So in this last part, we're going to look at problem solving with triangles. When solving triangle problems, first thing is to read the problem carefully. Second, of course, is to sketch a diagram and record the known measures. Next, identify any unknown measures you're looking for. And then choose the correct triangle relationship to solve for the unknowns. Here are all the formulas we've looked at so far. We have our right triangle formulas here, which involve the Pythagorean theorem, or our primary trig ratios, sine, cosine, and tangent. Next, we have our oblique or non-right triangle formulas, and they are the sine law and cosine law. And we also have our 180 rule. That works for both right triangles or non-right triangles. So let's go through a few examples and discuss how you know which formula to use when. So example 1, solve for the indicated side length. So we're looking for this side right here. We just go in order. We start with our right triangle laws. Do any of them work here? They could, but we don't know if this is a right triangle. So since we do not see a right angle in this picture, we're going to assume that this is a non-right triangle. And this means we need to use either the sine law or the cosine law. And we always start by looking if we can use the sine law first. And since we have a known side, and we can find this angle here, a known angle, using the 180 rule, we can use the sine law. So let's start first by finding our missing angle. So using our 180 rule, we get that. Actually, let's first label our diagram. So we have A, B, and C. So angle C is equal to 180 minus 23 plus 15. And that gives us an angle of 142 degrees. So that's this angle right here. Next, we're going to set up our sine ratio. So we know this is side C, and we know this is side A. Since we're looking for that, we're going to start there. And remember, we're going to use the version of our sine law. If we go back to here, this is the version of our sine law that helps us find sides, or easier for us to find sides. And this is the version to help us find an angle. All right, so starting with the version that helps us find a side, we are looking for side A. So that means we're going to divide by the sine of angle A, and the known ratio we have is side C over the sine of angle C. Subbing in our values, A is X, vertex A or angle A is 23, and side C is 33, and the sine of angle C we have is 142. Next part is to multiply both sides by the sine of 23 degrees. Because we have x divided by sine 23, we multiply by sine 23 to cancel the sine 23 from the left side. And we have that x is equal to 33 sine of 23 over the sine of 142. So the last part is just to use your calculator. And I end up with approximately 20.9, and the units we have are yards. So 20.9 yards is the measurement of side X. So once again, looking at the diagram, we have to determine which formula we're going to use. Since it's a non-right triangle, we skip to the sine law or the cosine law. And since we had a known angle across a known side, then we're going to use the sine law. Example 2. Right away you see you have a right triangle, so we're going to need a right triangle law to help us with this one. Let's label our diagram A, B, and C. So this is side C, this is side A. Our angle of focus is here, angle A. That's the angle we're looking for. So since we're using a right triangle law, we have to label our sides. The 10 feet, or side A, we can see that is opposite angle A, our angle of focus. And side C is our hypotenuse. So we need a ratio that has opposite and hypotenuse in it. And that ratio would be our sine ratio. So sine of our angle of focus A is equal to side A over side C, the opposite side over the hypotenuse. Next we sub in our values. So we have sine of theta, or sine of A, is equal to 10 over 24. And since we're looking for an angle, then angle A is equal to, remember, the sine minus 1, or the sine inverse of the ratio 10 over 24. And the last step is to use our calculator. So we get that angle A is approximately 24.6 degrees. So once again, since we had a right triangle, we go back to our right triangle formulas. We could have used Pythagorean theorem if we were looking for the third side. Since we're looking for an angle, in this one, we needed one of the primary trig ratios. And we chose sine because we had the opposite in the hypotenuse. Last example. I need to solve for side x. However, in this triangle here, I don't have enough information to solve for side x. So I've attached a second triangle to this, and they both share this one side here. So if I can find the length of that side, I can then use it to help us find side x. Let's look at this triangle here on the left. First thing, we may or may not need this, but we could find this angle here using our 180 degree rule. Before we do that, let's label. So this is A, this is B, let's say this is C, and we'll call this one over here D. Starting with the green triangle here highlighted, if I want to solve for the shared side, it is side A. So we're going to look for what A is equal to. Since this is a non-right triangle, I can't use Pythagorean's theorem, and I can't use sine, cosine, or tan. However, I have a known angle, across a known side. So I'm going to start by using the sine law in this first triangle. So let's set up that ratio. So we are looking for side A. That means I'm going to need to divide by sine of angle A. And our known ratio is side B. So here's side B over the sine of angle B. So let's set that up. So A is our unknown. We'll leave it as A this time. We have sine of A, which is 54 degrees, equals 6 over, and that's the sine of 77. We want to solve for A, so it says A divided by sine 54. So to get rid of the division of sine 54, we're going to multiply. The opposite operation of division is multiply. These will cancel each other out. We get that A is equal to 6 sine of 54 degrees over the sine of 77 degrees. Next is to use our calculator, and we end up with an A is approximately 4.98, or if we want to round, approximately 5.0 meters. So there is our value of A, the side that both these triangles share. So let's put that number in there. So now we're going to focus on this second triangle. Notice in this second triangle we have two side lengths, A and B. Let's label this one B. And we want to solve for a third side, and all we have is the angle between the two sides. So given the angle between the two sides, that means we're going to have to use the cosine law. Once again, we do not have a right triangle. We don't have a known side across a known angle, so that leaves us with the last law, the cosine law. So to find side x, in this case that is side C, I guess we want to call it there. So let's label that, that's side C. And this D, I'm going to call it A as well, just a different A. Actually, let's leave it as D. And this D is equal to this side here, 5.0, or side A of the other triangle. So we need the cosine law that has C attached to it because we have angle C. So let's go to that part. So we want to find side x, and we called that C. So that's C squared equals A squared plus B squared minus 2AB cosine of angle C. So we better have angle C in our diagram. And we do there. So I'm going to redraw this picture down here. So we have this triangle right here. So let's sub in our values. So C is our x. So we have x squared equals A is right here. That's 5. So that's 5 squared. That's B. So that's 8 squared minus 2 times 5 times 8 times cosine of angle C, which we know to be 93. If we evaluate the right side, we end up with approximately 93.187 units squared. Last step to solve for side x. Remember, this is x squared, so we're going to square root both sides of this equation. And we get that x is approximately equal to 9.6 units. In this case, we're using meters, so 9.6 meters. So let's go back to the top. We started by solving the left triangle here using the sine law, and then we finished that. We shared the information on the second triangle, and on the second triangle we used the cosine law to get the missing side length. And we'll note that here. We use the cosine law since we have two sides and a contained angle. So here are 5 questions for you to try, and good luck.